Okay, 7.5, our last section of Module 7, where we're going to solve compound inequalities and absolute value inequalities. What we mean by a compound inequality is that it joins two inequalities with the word and or. When we see and, that requires that we find the intersection of the two solutions we get from the inequality. When we see or, that means we're finding the union of the two solutions. With an absolute value inequality, we convert it or think about it in its compound inequality equivalent. And the key is the direction of the inequality sign. So if we see absolute value like this is less than some quantity, then we think of that as a um, and situation. So it needs to be between the negative of that number and the positive of that number. Otherwise, if we see the absolute value is greater than some number, then we think of it as the or interpretation. In other words, write the inequality with the negative on the right-hand side, solve that. That can be part of the solution, or solve the inequality as is, and that will also be part of the solution, like a union of those two solutions is the idea. It'll be a little bit more concrete when we actually get through the example. I'm just telling you that right now. Let's jump right into the example so we can figure out what the heck did I just say. All right, solve the absolute value of 5 minus 4x is greater than 9. So the first thing that we do when we have an absolute value equation or inequality, recall from our previous section, is we split it into two. We write one as is, and then the other with the negative of the number on the right-hand side or on the other side. So notice here in what's expressed in the write-up of this example that this one is just writing it as is. Since it's greater than, that's why we're using the or interpretation. And then let's talk about the uh, second writing where we do the negative of the number on the other side and make sure that we understand what's happening there. Because notice it says this, but it says less than. When we translate this absolute value to the second type of equation, the one with the negative on the other side, imagine we have multiplied -1 on both sides. So that we introduced the negative. So we kind of artificially or multiplied negative quantity into this inequality. And whenever we do that, like divide a negative on both sides or multiply a negative on both sides, we flip the direction of the inequality. So if it started greater and we introduce a negative like that, then we flip it to less than. So that's why the setup is, as you see there, less than -9 for the other equation or inequality. Then we're going to solve both of these, and I want to break out and show you for this first one. So I'll just continue in the purple for the first one. What gets us to that part that you see there, -4x less than -14? Well, that's recognizing that there's a number minus a variable less than a number. So move that number 5 to join with the number 9 on the other side, -5 on both sides, so that we can get them together on the right here. And then we'll have -4x coming down is less than -9 with -5 joined together, added together, is -14. So that's how we get to -4x less than -14. And then we want to go one more step here. Notice we have -4 times x. So to undo that, we would divide divide -4 on both sides. Divide -4. That creates just x by itself on the left. The -4 is divided. We've divided both sides by a negative, so we change the direction of the sign. We've done that twice now for this particular one. Not always will you do that action, but it's showing up in this example. -14 divided by -4, that's going to be positive since we have divided two negatives. And let's just express that 14 over 4 for now. That could be reduced by dividing 2 on the top for 7, 2 on the top bottom for 2. Divide 14 by 2 for 7, divide 4 by 2 for 2. So that's one way of expressing it. Over here, you see 7 over 2 expressed as a decimal. But I'm going to continue and write it in this way because I want you to get comfortable with just leaving things as a fraction like this in simplified form. We would want to translate this to interval notation, but let's wait on that until we have the other solution to join in union with this one. So let's continue by talking about going from this inequality, 5 minus 4x greater than 9, to the step -4x greater than 4. Yeah. From 5 minus 4x greater than 9. Notice this first step is going to be very similar. -5 on both sides to join with the 9. Sorry about that. And that's going to give us -4x left on the left. Now the number that results here is a little bit different this time because we have +9 minus 5, that gives us 4. Now we have -4 times x, so we need to divide -4 on both sides so that we get x by itself, and that leaves us x on the left. Now notice we've divided a negative, so we need to change the direction of that inequality, switch it from greater to less than here. And 4 divided by -4, that's going to be negative. And we're dividing one negative there, and then 1 for 4 divided by 4. So it can be greater than 7/2 or less than -1. Now for these, it can be helpful to kind of situate yourself on a number line. So let's imagine -1 right here, +7/2 over here, since 0 would be somewhere in between them. And what ground can we cover? If we're greater than 7/2, that's going to be going this way. Then less than -1, that's going to be going this way. Notice they both don't have the equal sign. And so that means our boundaries on both of them are going to be parentheses. So parenthesis here and parenthesis here, since neither one of them has the equal bar up underneath. Notice the green area trails off to very low, no bound. So that's -infinity on that side. Let me keep my color coding here. So -infinity, but this side is trailing off to, and then the other side is trailing up to +infinity. And remember, on our infinity bounds, we're always going to have a paren. We'll have a paren on that side and paren on this side. So to kind of set ourselves up with the number line to translate to interval notation, like you see here. And so let's write it now, taking from our diagram, -infinity up to -1, close, and this is either or, so we join with union and pick up on the other side with 7/2 going up to infinity. Now there's a little difference here because I chose to express with fraction rather than decimal. That's the same number though, 3.5 Same thing as 700. Okay. So what we've done there is we've taken that absolute value inequality, translated it to compound form. Since it was greater than the initial expression, we think of this as an OR case, and that translates to union in our final expression. So there's our first example. I know that this is very complex and a lot to take in, so just give yourself time for this particular section this week and in future weeks. You might need to practice or feel like you need to practice even in future weeks on this section. I understand. Let's pick up with our first practice problem here. Notice it's already expressed in compound form with and, so that means we want the intersection of these two solutions that we're going to find. Let's look at the left one first. Notice we have a number on the left and on the right. So let's add one and get more room here. This is not looking so great. Let's bend in a little. We can put the intersection of these two solutions. This one, we can see that this number term over here needs to move to join with this number term over here. That will leave us with 3x on the left less than 5 plus 1 for 6. Then we need to divide 3 on each side, leaving us with x less than 6 divided by 3, that's 2. So that's one part of the solution to consider. Now let's look at the other one. It looks like we have x plus 4 greater than or equal to 7. So we've got the number 4, which needs to move and join with this 7 on the other side, so that we have only variable term on the left. Greater than or equal to comes down, and 7 minus 4 is 3. Now, why don't we switch the order of the inequality there and switch it to less than or equal to? We're subtracting 4. We're adding a negative 4 to both sides. We're not multiplying or dividing a negative quantity. That's when we flip the sign, when we're multiplying or dividing a negative. So since we're just adding negative 4 to both sides here, or you might think of it as subtracting 4, that's an add or subtract operation. And that does not include flipping signs when we add or subtract something from both sides. It's only when we multiply or divide by a negative on both sides that we change the order of the inequality. Okay? So that looks good to go. We have x with no number in front of it. So we need that space where x is less than 2 and greater than or equal to 3. So let's map that out. On the number line, we would have 2 and 3, and 1, 0. So let's look at this. Less than 2 is this way. Greater than or equal to 3. Greater than 3 or equal to. And we use square bracket there, paren there, if we were going to translate this in that direction. But since this is, it needs to be in both. It needs to be less than 2 and greater than or equal to 3. Well, that doesn't exist, right? 1 can't be less than 2 and greater than or equal to 3. Or another test point, 4 over here. 4 is not less than 2 and greater than or equal to 3 like it is. So what's going on here? Let's just think about one more test point. I know it's kind of difficult since it's in the halfway mark, but let's imagine 2.5. Is 2.5 less than 2? No. Is 2.5 greater than or equal to 3? No. So what we're finding here is that there's no number that satisfies both of these solutions. And so how that translates in the end is that there's no solution. We can't express an interval that contains a number that satisfies both of these inequalities. And your online software will have you express these cases. It will tell you whether to type in no solution or to use like the empty set as an indicator that there's no solution. But that's what we're seeing here. No number can satisfy it being less than 2 and greater than or equal to 3. Mhm. Let's try this next one. Notice we have absolute value. This time, absolute value of 4x minus 1 is greater than or equal to 12. So we want to write out the two equations from the absolute value. The first equation will just be as is, dropping the absolute value down. So as is. The second equation, you're going to be introducing the negative. So 4x minus 1, negative 12. And since we're working with inequalities and introducing that negative, think of that like multiplying negative 1. So we switch the order of that term. Now we solve. So I add 1 to both sides here. Join those numbers up together on the right-hand side. And then we have 13. Then we have 4 times x, so a divided 4 is needed in that. Then that gives us x by itself is greater than or equal to 13 over 4. Just leave it like that for now and solve the other one. We have plus 1, and that leaves us with 4x. It's going to look a little similar for a little while, but then changes since we get a different number on the right-hand side here. Negative 12 plus 1, that's negative 11. Operation still looks kind of similar. We have 4 to divide. Final result a little bit different. X less than or equal to negative 11 over 4. Now you'll need to refer to the initial note a lot of times to decide whether this is an and or case. And since it is um, greater than, in this case, we translate that to, and I'm just going to model what I mean. Look back up here, see what happens when you translate to greater than. So here's your 2 bullet points. See, when it's less than, you do kind of this weird in-between inequality. But what that means is and up there when it's less than. That's the and case. When it is greater than, that's the or case. And as a point of reference, the or is right there. When you look back in your notes, so that can help you decide which one's or versus which one's and. Because unfortunately, I did not place the word and on the first bullet point. So what we have is like in the orange, we're looking at a greater than case. Okay, so let's take it back. We're looking at a greater than. The equal bar doesn't matter when you're deciding and versus or on the absolute value inequality. This is a greater than, which translates to an or interpretation. The x needs to be greater than or equal to 13/4 or less than or equal to negative 11 over 4. So let's just map this out. I'm going to place a 0 in the middle just to give us an orientation. We know negatives are to the left of it. The negative 11 and 4 would be somewhere over here. Positives would be to the right of it. The 13/4 positive would be over here. Greater than or equal to on the 13/4. So greater than and equal to means we'll use a bracket. Then on the other one, less than or equal to -11. So less than and can be equal to the square bracket. That goes down infinitely. We use paren on that side. The other side goes up infinitely. We use paren on that side. Paren's always on the infinity side. So let's now translate that to our final interval notation. Remember, or means union. So negative infinity to -11/4 union. Oop, I used the wrong symbol there. Back up a step. This could be equal to -11/4. Union could be equal here to 13/4. And comma is up to infinity, close paren. So there's our final solution. Let's try out one last example. I just want to point out before I clear this current example, notice this one is going to translate the less than interpretation of the absolute value inequality, and that's and. Okay. We saw a greater than example just a moment ago, for which we used the or interpretation. What we're seeing next is less than absolute value inequality, so that has the and interpretation. Oops, sorry there. Let me make that note again. And less than, it is just the and interpretation. We have a little bit of aside or setup work to do on this one, since it's not just like the last one. Let's go up and look at the last one. Okay. Notice this last one had absolute value already by itself, ready to strip away and convert to the positive and negative form. We needed it to look like that before we split it into the two forms. And notice down here with this example, that's not what we see immediately. So let's walk through what it is that I want you to do in that case. We need to subtract this number, because it's like 2 times absolute value plus number less than number. And so we treat this like, okay, need to join that number 3 with the 7 on the other side. When we do that, we get 2 absolute value x minus 5 left over here, less than 7 minus 3 for 4 over here. Now it's like we have 2 times absolute value of stuff less than 4. So we need to get rid of the 2 times. Divide 2, divide 2. So that leaves us with absolute value stuff. The 2's divide on the left. And then 4 divided by 2 on the right, that leaves us with 2. So just want to emphasize here, this was the thing we needed to get to before we do the splitting off into 2 equations. Okay. And then set up our 2 equations over here. All right, first one is going to be dropping the absolute values and writing it as is, x minus 5 less than 2. Second one, introducing the negative. So to introduce a -2 here, I need to flip my sign when I'm introducing the negative and setting up my 2 forms. All right, now solve. We have a 5 number term that's subtracted on the left that should be joined with this 2 on the right. So let's do that. Adding 5 to both sides will eliminate it on the left, leaving us with x is less than 7. So that was nice and quick. X is by itself already, no need to divide anything. Looks like this one will have similar starting operation, add 5 to eliminate it on the left, leaving us with just x greater than, and then -2 plus 5, that's 3, positive into 5 is larger. All right. And we need to join these with and. Mhm. So let's just read it. X is less than 7 and x is greater than 3. Let's just map that out, see if it can make any sense. Remember that last and example we didn't have any like corresponding area or numbers that would work. But sometimes they do. 3 here, 7 would be higher than 3, so it might be here on a number line. And let's just start kind of drawing out what's going on. Less than 7 means we're coming this way. And greater than 3 means from 3 would be coming this way. And notice how in this example, we're finding a region in which they agree. And that's when that happens with an and case, that's when you have something to express, that it's not just an empty set. All right, so let's talk about what do we need. If it's greater than 3 with no equal bar underneath, then there needs to be a paren next to the 3. If it's less than 7 with no equal bar underneath, then it's a paren on the 7. All right, so we're almost there. We've got 3 as the lower bound, comma 7 as the upper bound, paren on both sides. So there we have it. And that was the case in which we found corresponding joined region, and since it was an and case, that's ideal, um, so that we have some interval with numbers to express. Unlike that previous one where we were getting divergence or branching off to the left infinitely and to the right infinitely, they didn't have any agreeing regions in the last and example we did. Whereas with this one, we're seeing one that does have that kind of middle region or place where they agree. Now, I just want to state again, I know this section is going to feel very complicated. So start, just start, and know that you have plenty of time in, future weeks to continue your practice. Don't give up because this is complicated. You'll get it. Just start, make a start seeing where things make sense. Practice, 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 and we'll get there. Okay, so that concludes our Module 7 activities. Work on your homeworks for Module 7. Complete your Module 7 test by Monday, and we will pick up Tuesday. All right, I look forward to our next class, and we'll stop our recording now.